Assalamualaikum warahmatullahi wabarakatuh. We from Group 2 will present about our project, which is the Solar Power Smart Fire Alert System. My name is Muhammad Irfan bin Muhammad Azwi, ID number TC18040.
My name is Muhammad Zikri bin Zamzuri. ID number is TC18069, and our supervisor is Dr. Nur Intan Shafinas Muhammad. The outline of this presentation is we have introduction and objective, problem statement, literature review, methodology, result, last but not least, conclusion and recommendation. For the introduction, every building needs a fire alarm system for safety purpose. The fire alarm system installation must comply the procedure and guidelines regulated by Nation Fire and Rescue Department. Many cases of fire in the government buildings and offices occur because of short circuit and electrical appliance damage, faulty and misuse. These are the newspaper headlines for the cause of fire cases that occurs.
For our project, we have few objectives. First objective is we want to design a smart fire detection system for early emergency response. Second, we want to develop a programming coding for this system. Next, we want to evaluate the solar panel for power supplies and measure the performance of the system. Last is to determine the accuracy of this system. From the research background, we had come up with a few problem statements that focus on our research study. First problem is there are no early notification about the occurrence of the fire. Second, people died suffocated in smoke during the fire incident. Third, alarm detection system does not detect the fire incident fast enough. Fourth, there are no backup power supply when the main power are cut off. Next is the literature review. First is the Arduino-based home fire alarm system with GSM module. Next is the fire detector design of an automated quick response fire alarm system based on SMS. And this is the street drainage and building at 1944 Pahang PU 4/1996. And finally, the study by Senseng 2016 showed the experimental investigation of using CO sensor to detect smoldering fire in dwelling. Now we go to the methodology of this project. For our project workflow, first we will design the circuit and the testing model using Microsoft Visio and SketchUp Pro. Next, we will assemble the module and hardware components such as the Arduino, the GSM module and the power supply unit. Then, we will develop the programming code for the system using C language. We will test whether the code had error or not. If there's no error, the coding will be uploaded to the Arduino. All components will be installed into the 1010 skills testing model. Here, we will test the functionality of the system. If there's no problem, the system is well functioned and safe to be used. Finally, we will record all the data for the t-test analysis. Next is the programming flowchart. This flowchart shows the flow of C++ coding. When the fire broke out and the smoke and heat will trigger the temperature and the smoke sensor. Then there are two conditions to be fulfilled, which are the temperature need to exceed 40 degrees Celsius and the smoke concentration need to reach 400 ppm. If both conditions met, signal will be sent to the Arduino informing the high temperature and high smoke concentration. The Arduino will notify the GSM module and the LCD display. Then the GSM will send the SMS. The LCD will display fire alert, call 911, and buzzer and red LED will be triggered. This is our schematic wiring diagram that consists of Arduino Uno R3 act as the microcontroller, the power supply unit, that consists of solar power manager that connect with the solar panel, the battery, and also can be connected to the grid using the charger. And we also have the display control unit that consists of the LCD display, the GSM module, the buzzer, the switch, and also the LED. And we also have the sensor unit that consists of the temperature, humidity sensor, and the smoke sensor. This is the design of our 110 scale testing model. And for our sample, we use 10 gram and 5 gram of coconut husk and pepper. Next, we will show you our testing video. Now, for the result.
The result of this project is represented by this graph of accuracy testing of the system. The first graph shown that the temperature reading of the 4 sample of combustion against 5 minutes with every 10-second interval of time. The second graph shown that the smoke concentration of 4 sample and of combustion against 5 minutes of interval 10 second. Next is the t-test analysis of the temperature between the coconut husk and pepper combustion. The t-test analysis results prove that the various temperature from different type of sample can be detected by the sensor of temperature. Then the t-test analysis for smoke concentration between coconut husk and pepper combustion. The t-test analysis result prove that the various smoke concentration from different type of sample can be detected by the sensor of the smoke concentration.
For the recommendation to further improve this project is by using the IoT module for the better function and practicality. Next is adding more sensors that can detect various types of harmful gases for improvement of accuracy. Lastly is using the real scale of testing method to simulate the real fire occurrence with various types of combustion materials.
In the conclusion, this project is success to design and fabricate a smart detection system for an early emergency response. This system needs a minimum 5 volt of electrical energy to execute that required of at least 0.077 meter square of surface area of solar panel. The statistical analysis for accuracy of this system determined by t-test analysis, which is alpha is equal to 0.05. There are strong statistical evidence that shows that there is a difference in temperature, smoke concentration and humidity between sample coconut husk and paper.
These are the few references that we refer for this project. That's all from us. Have a nice day. Thank you.